So let us start with the preparation of alcohol. I am just recapping whatever we had discussed it yesterday. So preparation of alcohol, it can be obtained from alkene by acid catalyst hydration, and you got the mechanism here. Then it can be obtained from hydroboration oxidation, then mercuration demercuration, and then you have got the another method, that is from carbonyl compounds, and then we have got the synthetic preparation from Grignard reagent. So these three methods are applicable here for the preparation of alcohols, and I have made this as a sketch note here. Okay, so you please note down, this is the preparation of alcohol, and from alkene you can get, and there are three methods like hydration and then hydroboration, then mercuration, demercuration. And alcohol can also be obtained from carbonyl group by reduction. And here we can obtain primary alcohol from aldehyde and secondary alcohol from ketones. Then from our MGX, that is the Grignard reagent, we can have, that is the starting compound is HCHO to get primary alcohol, CH3CHO to get secondary alcohol, then acetone, CH3COCH3 to obtain tertiary alcohol. So about which we have already explained. You please watch our video that I have already explained in detail in that video. Okay, right. Now let us take up the next aspect, that is prepare, and I have discussed in detail about this in-text question also in that particular video. So please go through that and attend the worksheets, attend the questions asked in that video also. Now, preparation of phenol. So the phenol is represented as C6H5OH. So in what way it is different from alcohol? Alcohol is OH attached to saturated carbon, whereas phenol is the OH attached to unsaturated carbon. Okay, so that is why it's called enol or phenol. So here we have four important methods of preparation of phenol. One is from haloarenes. What do you mean by haloarenes? Arenes is nothing but aromatic compound that is substituted with chlorine. One hydrogen is substituted by chlorine. So you've got chlorobenzene. That is nothing but haloarene as a general one. And when it is subjected to, that is a fusion with the NaOH, that is when it is a molten with the NaOH, sodium hydroxide at the 300 atmosphere. So these reaction conditions are very important. Do you understand? And what do you mean by this 300 atmosphere? You know very well, our room atmospheric pressure is 1 atmosphere. You just imagine it is almost 300 times. So in such a way, we should be passed through the heavy pressure. So 300 atmospheric pressure. And it should be, you know, the room temperature. What is the room temperature? It is around 30 degrees Celsius. And 30 means 30 plus 273, how much? 303. So 303 means that is this much is 623. So very high temperature. Horrible follow. So high temperature, high pressure. So when you pass this chlorobenzene through this NaOH and it is fused. Fusion means what? Melting. So at that temperature it is molten. Is it not? So it is molten to become what? That is sodium phenoxide. This is called sodium phenoxide. C6H5ONa. And C6H5O minus and Na plus. So that is why you can split like this. So this is sodium phenoxide. So you are able to get this sodium phenoxide, and by hydrolyzing, for example, by introducing HCl, acidification, not hydrolysis, acidification, introducing HCl, the Na will have the affinity towards chlorine, so it becomes NaCl, that is isolated, separated, and the H combines with this so that you are able to get phenol. Okay, so this is a simple route from haloarenes. So what do you mean by haloarenes? Haloarenes is nothing but what? That is so the first method is from haloarenes. What do you mean by haloarenes? Arene means benzene based compound, aromatic compound. Halo means fluorine, chlorine, bromine, iodine. So let us consider chlorine. So chlorobenzene. So let us have chlorobenzene. Now this reacts with NaOH and the temperature is very important. So 623 Kelvin and 300 times the atmospheric pressure. So 300 atmospheric pressure. So it forms, that is, this Cl is totally replaced by, that is, NONA. Okay, so that you are able to get ONA. This is called sodium phenoxide. This is plus, this is minus. So that on acidification, it's Cl, Na combines with the Cl and it becomes H. It can form phenol. Why it is the enol? Because C, double bond C is here. Okay. So here you have H, 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 and this is OH. This is H, H. So alternative double bond. So we have the unsaturated carbon atom is attached to hydroxyl group, and that's why it's called enol. Got it? Next method of preparation, that is from benzene, sulfonic acid. So from benzene sulfonic acid. What is this sulfonic acid? You know sulfuric acid, H2SO4. This is sulfuric acid. And this can be written as HOSO2OH, right? Okay. Now, the benzene is treated with oleum. What is oleum? It is called fuming sulfuric acid. Take down. Fuming means very high concentrated. So, fuming sulfuric acid. That is known as oleum. Very high concentration. So, when it combines with, and you have got H, everywhere you have got H, let me specify this H. And this volume is nothing but OH, SO2, OH. So these two can combine to form water so that the residual is benzene sulfonic acid. Okay, so water is removed here so that you are able to get SO2OH. This SO2OH can also be written as SO3H. That is called benzene sulfonic acid. Got it? And this benzene sulfonic acid is further treated with sodium hydroxide followed by H plus. SO3H. So that is treated with first NaOH followed by H plus, that is acid, acidification. So that it gives you first, that is a sodium benzene sulfonate, and after that it is hydrolyzed to become OH, that is phenol. Okay. So this is the second method of preparation. Third method of preparation from benzene diazonium chloride. From diazonium salts. What do you mean by diazonium? Diazo. Azo means nitrogen. Diazo means the two nitrogen. So it is combined like this, N2. Diazo. And one of these nitrogen is having cation. So that is why it's called diazonium. And benzene is attached to that. So that is why it's called benzene diazonium. So benzene is attached here and you've got N2 with plus and Cl minus. So it's called benzene, take it out, benzene diazonium chloride. Okay. Now let us combine this with aniline, take it out, NH2. So first it is subjected to diazotization. This reaction is a very important reaction, diazotization. It means you are converting aniline into benzene diazonium chloride. How is it feasible? This is done at 0 to 0 degree, 0 to 5 degree Celsius. And if you want to give it in Kelvin, you can put 273 to 278 Kelvin. So this can be achieved only at lower temperature. And you have got NaNO2. Actually, you require only HNO2. But HNO2, nitrous acid is not stable as such. So it is freshly prepared and is freshly prepared from sodium nitrate and combining with HCl. So aniline plus NaNO2 plus HCl in the temperature 0 to 5 degrees Celsius is called diazotization. The product is benzene diazonium chloride. So this is benzene diazonium chloride N2Cl. Aniline 2, this is what is the name of the reaction? Aniline. This is called diazotization. Diazotization. So you are converting aniline into benzene diazonium chloride. Benzene diazonium chloride. And that is why it's called diazotization reaction. Okay. So what is the temperature? 0 to 5 degrees Celsius in terms of Kelvin, 273 to 278. Never forget this temperature. Okay, so once you are able to get this, from this you can have hydrolysis with warm water so that it will break. So OH and H and it will give phenol plus nitrogen plus HCl. Okay, excuse me. So this is phenol. So this is the third method of preparation of what? Phenol. Now the fourth one, cumene. Fourth method from cumene. Now let us analyze what is cumene. Cumene is nothing but isopropyl benzene. You know benzene, okay? And isopropyl means what? This is isopropyl group, CH3, CH3, CH. Now it is going to attach here. So that CH3 and then you can put simply like this, okay? So isopropyl benzene, that is nothing but cumene, right? Now let us consider cumene, that is oxidized. So you have cumene C H H3 CH3. Now what you do? Subjected to oxidation, that is passing oxygen. Okay, it becomes peroxide. So this H becomes COOH. So you are able to get a peroxide compound, cumene hydroperoxide. This is called cumene hydroperoxide. So you have CH3, CH3. Instead of CH, you will have COOH. This is called cumin hydroperoxide. Take down. Cumin hydroperoxide. And this cumin hydroperoxide, so this linkage is called peroxide linkage. Okay. Now here it is subjected to hydrolysis by acid so that you are able to get, that is, it splits like this. So you can get first this is broken like this. Okay. And here you are able to get OH and here H so that it gives you, and that is this is OH, that is phenol part plus, and CH3, this O goes here, this O goes here. So CH3, CO, CH3, that is nothing but acetone. One O goes here, and the OH plus H gives water. So water is released. Okay. So this is the main product, that is phenol. Okay. So what are the three important methods of preparation of, four methods of preparation of phenol? Phenol. Phenol can be simply represented by five. Five, one, two. Always put the clock diagram. So what is the first method, second method, third method, fourth method? From how to represent hair arrays, A or A. Okay. And what is the second? Benzene sulfonic acid, benzene sulfonic acid. How to represent that? 5, C6H5, SO3H. Benzene sulfonic acid. Where from benzene sulfonic acid was obtained? By sulfonation of benzene. That is, what is sulfonation? Treating with the fuming sulfuric acid. Right? And then here the third method is from diazonium salt. Okay. So here benzene diazonium from, actually it is rooted from aniline, but by hydrolysis of diazonium chloride, that is C6H5N2Cl. And how it was obtained? From diazotization. Diazotization from C6H5N2. What is the reagent here? NaNO2 and HCl. What is the temperature? 0 to 5 degrees Celsius or 273 to 270. Okay. So you should know this root also. And from cumin. So what we have done in cumin? We just oxidized it. Okay. Cumin. What is cumin? Which is nothing but isopropyl benzene. Okay. So where from we were able to get the phenol? From aryl chloride, that is haloarenes. Haloarenes. Second, benzene sulfonic acid. Third, benzene diazonium chloride. Fourth, cumin. Got this point? Is it clear? Now let us move to the next one, physical properties. Okay, with them. Physical properties, mainly, what are physical properties? Boiling point, melting point, viscosity. So these are all physical properties, even color, crystal nature, etc. So whether you had to define whether it is solid or liquid or gas, and if it is liquid, what is the boiling point, etc. So all these are discussed here. Here, boiling point is very important, being a liquid. So, this is alcohol, is it not? ROH, and then HOR, and then HOR, and then HOR. You are able to find out the hydrogen bonding between the molecules, among the molecules, right? And what about the phenol? There also you are able to get this intermolecular hydrogen bonding. Are able to follow? So it involves what? That is intermolecular hydrogen bonding. What is hydrogen bonding? Hydrogen bonding is nothing but what? It is a bond developed between hydrogen, that is proton, and nearby electronegative atom. Okay, so what is H bond? H bond is nothing but the bond developed between electronegative atom and the nearby hydrogen atom and the nearby electronegative atom. In the case of alcohol, let us say alcohol or CH2OH, or you can simply put ROH also. So in that case, R, and then it is given as O, then H. Once again, H, and then O, then R. So likewise, you can find the intermolecular hydrogen bonding, and that is responsible for the high boiling. Okay, so what are the key points to be discussed here? Now, alcohols phenols consist of two parts, alkyl group and the hydroxyl group. Okay, so it is because of the presence of hydroxyl group, their properties are different. For example, when you look at alkane, it is gas, but when you consider alcohol, when you consider methane, let me consider methane. What makes the difference between methane and the methanol? Let us discuss like this. CH4. And what about methanol? CH3OH. Okay. So it is gas. This one is gas, whereas this is liquid. Why this nature changes? Is it because of one oxygen? Yes, because it involves in intermolecular hydrogen bonding. And there is no such oxygen here. That is why it is gas. Whereas here it involves in intermolecular hydrogen bonding. Okay. So actually that is when you take any liquid. Okay. Let me consider three boxes. This is solid, this is liquid, this is gas. In the case of solid, the intermolecular force of attraction is very, very high. And that is why it has got some fixed, or not only intermolecular force, this is called intermolecular force of attraction, is very high. In the case of gas, it is very low. In the case of liquid, it is in between. So, in the case of gas, it is very low. It means what? Intermolecular force of attraction is very low, and that is why the rate of diffusion is very high. So, it behaves like a gas. Whereas in the case of liquid, there is some intermolecular force of attraction. And with all that, you have got intermolecular hydrogen bonding also because of the presence of oxygen. So that is why I have explained here how this hydrogen bonding is developed. So that is why you are having a liquid, that is alcohol as liquid, and that too when it increases, when the hydrogen bonding strength increases among the alcohols, naturally the boiling point also increases. Okay, so please make a note of it. When intermolecular hydrogen bonding strength increases, it also increases with the, okay, so boiling point also increases. That is another interesting point to be noted. Now, so I was talking about this intermolecular force of attraction, and that is nothing but van der Waals force of attraction, VWF. Okay, so this is nothing but van der Waals force is nothing but intermolecular force of attraction. Really. Okay, so the boiling point of alcohols, phenols, increase in the with the number of carbon atoms. So when the number of carbon atom increases, the boiling point also increases. In alcohol, the boiling point decreases with the increase of branching in carbon chain because the decrease in van der Waals force and the decrease in the surface area. So when the branching goes up, okay, when there is a branch, definitely this van der Waals force comes down, and that is why the boiling point here decreases. Or you will follow. So you have to make a note of this one. Then the boiling points of alcohols and phenols are higher comparison to other compounds, other classes. For example, hydrocarbon, ether, haloalkanes, haloarenes. With all that, the boiling point of alcohols and phenols are high. The BP is high. Why? It is because of intermolecular hydrogen bonding. How this intermolecular hydrogen bonding takes place? It is because of the presence of electronegative atom. And what is that electronegative atom? That is nothing but oxygen. So it is an additional binding force and that is responsible for the elevation of boiling. So that increases the boiling. You understand this? Now, when there is a branching, naturally this intermolecular force comes down and the surface area, okay, so um, that decreases, and that is why the van der Waals force also decreases, and in turn the boiling point decreases. So for branched item it decreases, for linear one it increases. Okay, then you just look at it here. You have ethanol. You have, what is this? Acetone. What about this? Alkane. You just look at the boiling point. For example, when you note down the boiling point of, let us compare the boiling point of, that is, take down CH3, CH2OH. This is alcohol. Then CH3O, CH3. This is acetone, ketone. Then CH3, CH2, CH3. That is propane. So what is this? This is alcohol. That is ethanol. What about this? This is acetone. That is a ketone. What is this? This is propane, that is an alkane. Okay. In all these three cases, listen to me. What is the molar mass? Let us calculate the molar mass. What is the molar mass? 12 plus 12, 14. Is it not? 12, 14, 24. 12 plus 12, 24. And this one, 24. 24. 6 30, then you have got 16, that is 46. So 46 is the molar mass. And what about this one? 12 plus 12, 24. Hmm, that is also 46. Okay. And what about this? This is 44, 44, right? Now you just compare the molar mass, it is almost similar. These two are same, and this is slightly less by 2. But even then, when you look at the boiling point, look at the boiling point of ethanol. This is 351 Kelvin. What about this? This is 248 Kelvin, right? And what about this? This is 231 Kelvin. Okay. And what is 0 degree? 0 degree Celsius is nothing but 273 Kelvin. You just compare with the 0 degree Kelvin. It is higher than 273. It is lower than 273. It is much lower than 273. It means this is a gas and this is a liquid with a low boiling. This is a liquid with high boiling comparatively. Are you will follow? So this boiling point difference arises because of the presence of O. You may argue, sir, here also you have O, but in this case, as a ketone, there is no left out hydrogen here to involve in hydrogen bonding. Whereas here you have got O and H separately, so you can involve in hydrogen. Here, this oxygen is flanked by two methyl, okay, and that is why it is not directly accessible. Whereas in this case, it is separately available as OH, okay. So intermolecular hydrogen bonding is very, very important, okay. So the high boiling, so boiling point increases mainly due to the presence of what? The increase of intermolecular intermolecular hydrogen bonding. Okay. Whereas this is lacking in alkane and acetone also. Now let us talk about the solubility. So what do you mean by solubility? Solubility means that is how far that can be dissolved in water, water solubility. So let us talk about now solubility. Take down solubility. So here solubility in water. We talk about alcohol and the phenols. Okay, they are soluble because of their ability to form once again the hydrogen bonding with the water. Here, the presence of hydrogen bonding that is responsible for high boiling. Whereas here, the formation of H bond with water. Okay, so that is responsible for solubility. So actually the solubility decreases with the increase in the size of alkyl and the aryl group because the alkyl part is always hydrophobic because it consists of lot of carbon atoms, okay, covalency, and that is why increase of carbon definitely decreases the what? The water solubility. Are able to follow, and that is why low molecular mass alcohols are miscible with water in all proportions, whereas a higher molecular weight alcohols are less soluble in water. Okay, so this is regarding the solubility parameters. Okay, right. And next, that is chemical reactions. So, what are the two important properties we have discussed here? One is boiling point, another is solubility. So, boiling point for alcohols and phenols are high because of what? Because of intermolecular hydrogen bonding existing in the molecules, in the compound. Whereas solubility, lower alcohols are soluble in lower alcohols and phenols are soluble in water. Why? Because it can very well form the hydrogen bonding with water. Okay, so that is the reason. Okay. And when you increase the number of carbon atoms as a chain, definitely that decreases the solubility. Okay. And when you increase the branching in alcohol, that decreases the boiling point. Okay. Next, chemical reaction. Take down. So in chemical reactions, we have of alcohols. We can discuss in this way. For example, first of all, you should know alcohols as a nucleophile. You just go through this point. Alcohols as nucleophile. Okay. ROH. Now listen this point. Nucleophile means what? That is you've got this bond O, then H. What is this? Alcohol. You've got two lone pairs of electron. Take down on oxygen. Now when it combines with the carbonium ion, so a pair of electron can be transferred like this, so that it forms what? That is R and then O. Here it becomes plus. Why? Because a pair of electron is given to carbon, and still you have got a H here. Okay, this H, and then you have got another pair of electron. Okay, now that gives what? It is attached to C, right? Then it is left over like this. Now you know this is the carbon, that is carbonium ion. Okay, carbonium ion. What is this? Carbonium ion, carbon atom bearing positive charge. Okay, and the alcohol, since this oxygen present in alcohol has two lone pairs of electron, so they are electron rich. So the electron rich entities are called nucleophile. Why? Because it goes towards the nucleus, that is carbonium ion. You understand? Okay. So this acts as nucleophile. Take down. So this is alcohol as nucleophile. What is nucleophile? Nucleophile is the nucleophilic agent that approaches, it is the negative entity or electron enriched entity that goes in search of carbonium ion. Okay, and that is why alcohol acts as nucleophile. Got it? Now, followed by this, after the attack of nucleophile, nucleophilic attack takes place. And here, this this is removed as proton, finally. So it gets stabilized so that you are able to get RO and then C, then the H is released as proton. Okay, so this is the general mechanism adopted in alcohol when it acts as nucleophile. Okay, delta. And at the same time, when you acidify, that is protonated alcohol, take down. What is that? This is called protonated. Proton means H plus. So protonated. Protonated means by adding H plus. Okay, they act as protonated alcohols, act as electrophile, just opposite character. Okay, now let us look at this. We have RCH2 OH and the proton attacks. Okay, so it becomes what? That is RCH2, okay, RCH2, and then H plus comes here. So it means OH2. So it becomes, in this case, plus. Okay. You may tell that, sir, is having minus like this. Okay, two pairs of electrons similar to this. Yes. But the thing is, because of the approach of H plus, okay, instead of alcohol attacking as a nucleophile to H plus, the H plus attacks here. So in that case, it acts as electrophile. So it depends on with which it combines. Are you able to follow? When it combines with a powerful carbonium ion, then it acts as nucleophile. When it's combined with the H plus, then in that case, this becomes electrophile. Do you understand? Are you able to follow? Right. So, and you are able to get now plus. Okay. So once you got plus means definitely it can transfer like this by the approach of Br. So let us consider Br minus some halide. Okay. So halide, this comes here and you got this CH2, put R down like this. And now we have OH2 and here plus. Now listen to me carefully. Here it comes, I mean this bond, it goes up here in order to satisfy this plus. So that H2O is removed. So H2O is removed. And what happens? That is, so that it becomes a plus. When it goes here, this becomes plus. When it becomes plus, okay, partially plus means it will attack here. And that is why it acts as an electrophile. Are you able to understand this? So that you are able to get Br, CH2 and R, then that's plus H2O. So you are able to get a brominated compound here. So it means based on the nature of the cleavage, like that is sometimes OH is cleaved, sometimes the CO bond is cleaved. Okay. The reactions of alcohols and phenols can be divided into two groups. Okay. So first, let us discuss about this general nature of alcohol, where the alcohol can act as nucleophile as well it can act as electrophile. So these 2 points are very important. Now we can proceed with the second type, that is reactions involving OH bonds. That is one type of reaction. And the another is the reaction involving carbon oxygen bond is broken here. So how it is broken? So likewise, we have got the two major divisions. Okay. That includes, because when you talk about OH, you can include phenol also. Okay, so we are studying simultaneously both alcohols and phenols, right? And now let us consider the OH bond. So whenever let me discuss generally. Let me consider CH3OH. Okay, that is C. Let me take it. Okay. So what are the possibilities of that is breaking the bond? After all, chemical reaction is nothing but what? Cleavage of old bond and formation of a new bond. Is it no? So in that case, either this OH can be broken. Okay. This is one type, and that is why they are taken reaction involving cleavage of OH bond. Okay, please take down. So reaction involving cleavage of OH bond. And another one, a reaction involving, go to the third page where you have got reactions involving cleavage of carbon oxygen bond. Is it not? So where is this carbon oxygen bond here? Okay, another breaking. So this is type 2. So this is CO bond breaking. Horrible follow. So likewise, you can classify. Okay, which is the function group here? OH is the function. Okay. So in which case OH as a whole is cleaved in the first case. Because OH itself is totally released here because of the breakage of CO. When the bond between O and H is cleaved, you are able to get another type of reaction. So likewise, we can generalize the entire chemical reactions into two. One is the chemical, what are the different chemical reactions associated with the cleavage of OH bond? Another is what are the chemical reactions associated with the cleavage of CO? So likewise, we can broadly classify. First of all, let us list out all those things. In fact, chemical reactions is over. That's all. Whether it is alcohol or phenol. Okay. Now let us proceed. What are the different types of acidity of alcohols and phenols? Okay. The first one is acidity. Take down. Point number one, we talk about the acidity. What is this acidity? Acidity means the release of H plus, is it not? And that is why we talk about acidity because when OH bond is broken, H plus is released. That we already see. So the proton is released. Acidic nature is nothing but nature of release of H plus. So let us talk about the acidic nature of alcohol. Are you able to follow? So acidity of alcohols. You have to say acidic nature of alcohol. So this is first point. Second point, esterification. So second point, esterification. This is nothing but, for example, just like in the case of neutralization, right? In neutralization, in inorganic chemistry, we discuss acid combines with a base to give salt and water. So similarly, you've got acid here. For example, acetic acid is a weak acid, and which is having the similar base. It has got OH, that is alcohol. So they combine to form what? Ester. Are you follow? So that is why we call it ester. Okay. So this ester is resulted along with water formation. Okay, so that is why it's called esterification. Are you able to follow? So this is the second reaction under the grouping of cleavage of OH bond. Okay, so when you study, you just follow me how I am approaching. I'm taking the topics, subtopics, and all together. That is, I am generalizing everything. Then only I go one by one in deep separately. Okay. For instance, esterification, we have finished. Then, now that's all. So these are the two aspects associated with the OH bond. So we have made it very simple. Okay. See, when you go to the street, you've got a lot of houses. First of all, what you are supposed to do, you just count the houses. You need not go to each and every house and how many rooms are available there. Don't worry about that. If you go like this, you will stop with one house only. If you want to completely analyze about the street, what you are supposed to do, this is the main street. On the right side, how many houses? On the left side, how many houses? Finished. So likewise, we are approaching. So on the right side, you've got the cleavage of OH bond. How many houses? Only two houses. Acidity, esterification. But in each house, they may be having different rule. You need not worry about it first. Now let us come to this. Reactions involving cleavage of what? CO bond. So where you have a reaction with the hydrogen halide. So this is first reaction. A reaction with the hydrogen halide means HX. In a simple way, you should be able to write down. And what is the second reaction? That is the reaction with the phosphorus trihalide. So reaction with the phosphorus trihalide means PX3, PCl5, PCl3, PCl5, etc. Okay, this is PCl3. And third one is removal of water. That is nothing but dehydration. Put H2O. So water is going to be removed from this dehydration. And where you have got some mechanism here. And you have got oxidation. What do you mean by oxidation? Addition of oxygen. So there must be some oxidation. Okay. Then and next one. That's all. Then we are exclusively discussing about the reactions of phenol separately. Okay, so that is a separate topic. Okay, so we'll discuss about phenol later. Now, and in between we'll be discussing phenol, but we are discussing special reactions associated with phenol because it is having aromatic ring. Okay, now we have these how many reactions? Only five reactions, that's all. So what do you mean by acidity? The release of H plus. What is esterification? Alcohol plus acid gives what? Ester. That is not salt. Ester and water. And in this case, that is a hydrohalogenation, H plus, HX. And this one, PX3. And this one, removal of water. And this one, oxidation. So oxidation, when alcohol is oxidized, it gives aldehyde, primary alcohol. Secondary alcohol, tertiary alcohol, ketone with less number of carbon. But it is difficult to oxidize, but using powerful oxidation agent, you can do so. Okay, right. Now let us go ahead with the first one, that is this acidity. So acidic nature, how you can interpret the acidic nature. So I think now I have clearly explained. This is the sketch note of what the properties of alcohols and phenols, and that will be a separate topic regarding special reactions of phenol. Okay. Now we are talking about generally chemical properties of alcohols and phenols. Okay. Now, what are the physical properties we have discussed? So we can combine this. So these are also, I mean, in chemical properties, we'll do like this. We can have a total ROH and OH phenol. Okay. Now, this is the preparation part of it. And here you are discussing about the chemical properties. In between that, you are discussing about the physical properties. And here you are discussing about the uses. So whenever you take any compound, all these three are very important. Four are important. Chemical properties, physical properties, uses, and followed by preparation. And along with preparation, you should be aware of some structural aspects also. So you take any organic compound, okay, the and when you say structure, along with that, you should know about the nomenclature also, IUPAC naming, okay, IUPAC naming. So point number one, 2, 3, 4, 5, 6. So all the six are very, very important. You take any compound, whether it is acid, whether it is alcohol, whether it is a phenol, whether it is halogenated carbon, etc., anything, hydrocarbon, anything, even aldehyde, ketone, carboxylic acid, amines, biomolecules, you take anything, all these six are very, very important. You should be, first of all, be thorough with what IUPAC nomenclature and the respective structure and the classification. Then if there is any isomeric properties, you should include that one also. And if there is any polymer, you should discuss about that polymer also. And they will be definitely coming under uses. And what about the preparation? You have to do it exhaustively. And the physical properties, like boiling point, melting point, solubility, etc. Under chemical properties, okay, so how the bonds are cleaved, and based on the cleavage of bond, you can work out the chemical properties and uses. That's it. Okay. Now let us consider the chemical properties. So how we are done this chemical properties of, so this is called the concept. So in such a way you have to proceed. Chem properties of what alcohols and phenols, OH. So how we divided this? In the first one, second one, third one. We talked about, that is, the alcohol can act as what? Two, nucleophile and electrophile. Okay. And secondly, we discussed based on the OH bond cleavage. And third, that is a CO cleavage. Okay. So these are the major aspects. And what about this? Here we talk about one, acidity, acidic nature, two, esterification. That's all. And here we have four important properties. What are those? HX, reaction with the HX, reaction with the PX3, reaction with removal of water, then oxygen, oxidation. That's all. Okay. So this is the overall summary. And based on that, you please go one by one. And please watch my videos also. That will be very useful. And if you don't follow, or you are unable to understand some of the important steps explained in the acidic nature, then acidic nature of phenol, then the reactions involving CO bond, etc. You kindly ask me. And you've got a separate reactions like a phenol. I have detailed in a separate video about this. So where we will be talking about the electrophilic substitution, aromatic substitution, then Kolb's reaction, Reimer-Tiemann reaction, and all these named reactions are very, very important in alcohols. And you should discuss about the commercial preparation of alcohol, that is industrial preparation of alcohol. So there is a difference between manufacturing and preparation. Preparations are made in laboratory, but when it is commercially scaled up, then the raw materials should be available easily. So that is why here we take from atmosphere, because from atmosphere you can take carbon dioxide. From carbon dioxide you can convert this into carbon monoxide, and you can also take hydrogen. So for industrial preparation, the raw materials should be cheaper. Okay. And similarly, ethanol can be manufactured using this sugar cane. Okay, so that is why we take sugar, and we that is using the fermentation technique, we are able to that is convert the sugar into glucose and fructose, and finally make it as ethanol. So these are the commercial aspects about the commercial preparation of alcohol. And as far as the ether is concerned, similarly, you have got preparation of ether and the physical properties, then chemical properties. Generally, ethers are chemically inert. Okay, they are not so reactive like alcohol. Okay, why? Because this oxygen is not freely available. It is flanked between the two alkyl groups, so that is not so easily accessible. Lower ethers are useful in extraction studies. Okay, because of low boiling nature. And we'll be discussing here also the CO bond cleavage. Okay. Then, and we'll be talking about the electrophilic substitution ether also. That involves the aromatic compound. Okay. So with this, the entire alcohols and phenols are over, and kindly go through the videos. I think that is I'm able to give you some overview about this alcohols, phenols, ethers. So with this background, I believe you will be able to successfully complete all the videos. And if you come across any doubts, kindly ask me precisely. I will explain so that we can save our time. And not only that, try to do all the in-text questions and try to, because it contains a lot of work. It is not numerical problem, but these are all reasoning and the logical problem, especially with regard to boiling points, melting points, and solubility. So they will give different gradations, and you have to say whether arrange in the increasing order or decreasing order, and you should know why all this is. Okay. So those particular aspects can be discussed in the subsequent classes, provided you complete all the basic concept reviews here. Okay. Right. Any doubt? So better that is complete all